Welcome to Study Loop.
So in this problem, we are given the reaction of the formation of methanol from carbon monoxide and hydrogen gas. And in first part of this problem, we have to find out the value of del H naught for this reaction. And we can find out that, as we know, the del H naught value for reaction is the del H naught for the formation of its products minus the del H naught value for the formation of reactant. Now, and we have to find out these values from the appendix C of the book. So if we look at the thermochemical data um, from the appendix C of the book, we'll see that the del H naught value for the formation of methanol in gaseous condition is minus 201.2 kilojoule. And for carbon monoxide, the reactant, the value is minus 110.5 kilojoule. And for hydrogen, the value will be zero because in case of the standard states, um, for all the elements, the del H naught for the formation value is zero. So for hydrogen, the value will be zero. So our reaction equation will be like this. And from here, we'll get a value of minus 90.7 kilojoule. So this is the value of the del H naught for this reaction. Now, in B part of the question, we are asked to find out whether low or high temperature will maximize the equilibrium yield of methanol. So from the equilibrium constant value, we can see that since it's a negative value, that means this reaction is exothermic. As we know that the negative value of del H means um, a reaction is exothermic, or the reaction forms or produces heat. And that's why increasing the temperature, or in case of high temperature, the reaction equilibrium will go left to produce some reactant and minimize um, the effect of the change in increase of the temperature. So, and if we have low temperature, that means it will produce some of the products which will also produce some heat and will increase the temperature. That means in this case, low temperature will maximize the equilibrium yield of methanol. So for part B, the answer is low temperature will favor the maximum yield of methanol. Now in question C, we are asked whether or not high or low pressure will maximize the equilibrium yield of methanol. Again, high pressure means low volume. So if this is a normal or regular pressure, and if we increase pressure, apply higher pressure, the volume will be like this. And that means when you apply pressure, the volume is decreased. And in that case, the equilibrium will go away where it will have lower number of molecules present. That means in which side of the reaction we have lower number of molecules, in case of high pressure, the equilibrium will go that way. So from here you can see in our reactant side we have one carbon monoxide and two hydrogen. That means total three molecules. And the product side we have only one molecule of methanol. That means if we increase the pressure, or if we apply high pressure, and since that will decrease the volume, and the reaction equilibrium will go right to produce methanol, since it is lower in number. And that's why, and in that way, the maximum equilibrium yield of methanol will be achieved. That means applying higher pressure will shift the equilibrium to right to produce more methanol, and that's why this reaction will be favored by high pressure.